Welcome to the third video in this mini-series where we are looking at some of the maths used in nanotechnology in relation to indices and exponents. So this video is going to be more of a work through of some problems which will then use the rules that we discussed in the previous video, which you can see a link to just above me. So the first one is addition. So in nanotechnology, we often have to add small numbers together. So I'm just going to use a couple of examples to show you how to do maths with exponents. So let's say we have something which is 1.5 micrometers, and we want to add that to something which is, say, 200 nanometers. So what we can do is we can convert this all to the same units to add them together. So we can convert this to be in 1,500 nanometers. We can add that to 200 nanometers. And we can get the answer that this is then equal to 1,700 nanometers. Similarly, we could have solved this by converting it all to microns, in which case we could have also said that this was equal to 1.5 microns plus 0.2 microns, and then we can add those together to become 1.7 microns. So we are just converting units, and we can do that with some of the maths we've done in the previous videos. However, what we can also do is write this in terms of meters. So if we were going to convert this into meters, obviously we'd have to put a lot of noughts in. This is where doing maths using the scientific notation of times 10 to the power becomes useful. So we can write these two numbers in meters, so that's 1.5 times 10 to the minus 6 meters, and we want to add that to 200 times 10 to the minus 9 meters. When we do an addition of this form of powers, what we need to do is make these exponents equal to each other. So we need to do a bit of conversion here. So we could take this and make it all times 10 to the power of minus 9. So in which case 1.6 meters. To convert that into something which is times 10 to the minus 9, we can do that trick of counting. So we have to move the decimal points 3 spaces to the right. So this is then 1,500 times 10 to the minus 9 meters. I'm going to add that to the 200 times 10 to the minus 9 meters. So the meters stays the same. We can now add these two together. So we take the numbers, we add those together. So that's 1,700. This stays the same because we converted. This is effectively units. So we're just replacing from the previous board the nano, or the ends, with times 10 to the minus 9. So this is how we have to do addition in scientific notations. We always have to make sure that these exponents are the same, and then we can just do adding the same as normal by adding these two numbers together, or three numbers, or however many you want. So now let's do the same with subtraction. So just for convenience, we're just going to change these positives to negatives. So we can do the same trick of converting everything to times 10 to the minus 9, because with subtraction you have, same as addition, you have to make sure your exponents are the same. And in this case we can do exactly the same. We're just going to take this number away from this number, so that will be 1300 times 10 to the minus 9 meters. We could of course convert this into another number by moving the decimal point and changing this to 6. So we could also say that this is equal to 1.3 times 10 to the minus 6 meters by just converting this and moving the decimal points the other way, and therefore taking 3 off that number, or adding 3 to that number because we're in the negative.